just want to highlight one thing, that in Clean Air Fund report, there was a loss of in billions just because of the air pollution, whether it is indoor or outdoors. Our core forte is for the IAQ as well as the energy saving on the filtration side, and we have some of the few live cases with us. So as of now, I'll highlight one of the case for hospital industry. So in hospital industry, as previous speakers has already mentioned, that there's a system pre-filter, fine filters, and then there's a HEPA filter. They can't replace HEPA, but yes, they can replace the mechanical filtrations with the electronic ones, so that they can have a lower static on the filtration side and similar efficiency at par with the MERV 14 level of filtrations. So this we have attained approximately 20% of the savings on the HVAC system, and moreover, those kind of filtrations or any kind of electronic filtration, they have a lifespan of 7 years at least in the environmental of Indian conditions. So it depends on how they maintain, how they maintain those filters, and 7 years there's a no recurring for the same. So and in electronic filtration, the material which is being used for those technologies, they are again upcyclable and recyclable material. So in case of HEPA filter or any other techs which are thrown to the atmosphere, so our motive of sustainability or the clean air is not achieved. So once we capture those particulate matter or any other microbial contamination on the surface of those filters, we are just throwing to the atmosphere or dumping in the dump yards because of the higher cost involved in the upcycling of those materials or the recycling. So then whatsoever has been captured, it is again prone to the atmosphere. So it is again went to the outdoors. So our whole goal or the motive of IAQ or reducing pollution is somewhere compromised. So as already mentioned that in AHUs, we can save energy from the filtration side. So provided is their DPT switches, differential pressure switches are in working condition, and they should be in sync with the variable frequency drives which are there. If not there, then it is recommended to provide or to install the VFD drive so that we can have a automatically power saving on the motor side itself, because ultimately lower the static, the power saving would be there, and with the due course of time it will depict that when is the time to clean the filter. The sensor should be there, and the monitoring should be real time on a continuous basis. It should not be like we have done monitoring for weekly basis or fortnightly or quarterly basis. So that is not the right approach to do. Plenty of the players or the plenty of the clientele who have real time monitoring, they have data. If you have data, you can make decision out of that. If you have lower data or intermittent data or weekly or monthly data, how would you make a decision out of the same? So there, currently what is happening in plenty of the HVAC sites, so they have a chart system, right? If they put that 15 days are pending or 20 days are pending for the cleaning, so they will do the cleaning on the 20th day or the 15th day, which is marked in that particular chart sheet. So for an example, if the floor of that client is at a number 3 or number 4, for example, if we take an example of 4th floor, and their fresher duct is same, and there's a construction going on or the retrofitting is going on the 5th floor or either on the 3rd floor, so the whole filtration whatsoever is at the 4th floor, that is going to be choked prior to their time. So but their chart depict that there are 20 days pending for the cleaning. So they, if they don't have sensors deployed, they don't have DPT switches deployed, they don't have energy meters deployed, they are not in a position to get the data, how much power they are losing, how much money they are losing on the same. Nowadays, there are plenty of devices available. There are plenty of IoT equipments are available, which can give you the insights. You are sitting in any place of the world, you can have the data within your laptops or dashboards or the mobile phones. So you can access that, you can make decision out of the same. So that is what we are doing at Vayuguard. So these are some of the key factors which I have highlighted. So choosing filtration is the critical aspect. As per the requirement, the client or the designer should choose the filtration according to the site's requirement. It's not like that uh, uh, we have to treat PM 2.5 or PM 10. For example, if we talk about Delhi NCR, so it is having three adjacent locations. One is Noida, one is Delhi, and third one is the Gurgaon. All three have altogether different prominent pollutants. So if we talk about Gurgaon, there is a problem of PM10, that is the prominent pollutant in the pyramid. And if we talk about Delhi NCR, PM 2.5 and vehicular emission is the major contamination. And if we go to the Noida, SOx NOx is the top of the pyramid in the pollutant list. So accordingly, we need to design or we need to check which filtration is required rather than putting up just whatsoever is there in the specs or something like that. So it is our and designer's role to choose the right filtration which is required. And then uh, maintenance teams or the facility teams need to ensure that maintenance of those filters are in the right time, right place, and replacement of those filters should happen. So I have seen plenty of these sites where they wash the filters. I guess previous speakers would agree with me that plenty of mechanical filters from the OEMs are not recommended to wet wash. They are just for the vacuuming or blow or blow dry of the same, or the vacuuming of the same can be done as per the OEM's recommendation. Few filters are not washable as per the OEM's recommendation, but every site they just wash the filters, and after washing those filters the efficacy drops down. So that is one thing. And retrofitting in the filtration. So now there's an example of DLF, I guess, with us. So they just retrofitted their filtration, and now they are showing or showcasing that in their every site. So if you get a chance to visit any of the site of DLF, so when you enter in the lobby of there, so they are depicting their air quality, what is outside and what they are maintaining inside. So they have retrofitted the filtration. So whether it is mechanical or electronic, it's their call. But yes, plenty of the builders are doing that. So the real-time analysis or data gathering should be there so that they can have historical data as well as the real-time picture with them, so that they can make decision out of the same, that when is the time to clean the filter and when the life cycle of that filter has been exhausted and now it is time to replace the filters. So currently we are working on the same. So we have already filed an IP for that particular thing. So we are designing a solution which will give the insights on the predictive analysis. So there is a comparative of the data. For example, they have chosen XYZ, whatsoever brand they have chosen. So they will be having the data sheets of that filter and the test reports of that filter. We just have to compare the data sheet with the real picture or the real data which we'll be gathering with the help of sensors, and we will be comparing how much cleaning of those filters time is left and how much time is left for their life cycle. So it's a system. For example, the chart system should not be there. So it should be a realistic picture with them so that they can make a decision when to clean, when to replace. So nowadays, every AHU is equipped with the VFDs, but to get the insights for the same realistic picture, so DP switch, which should be in working condition and in sync with the VFD drives. So automatically, the when the static is low, automatically the VFD run at a lower hertz. So power saving would be there. So these are some of the calculations or the example theoretical calculations which I have made out, and there is a 4 to 5% limitations in the same, or in if we compare it with the actual numbers, so 5% of variations will come down. So, but 18 to 20% power saving is there for sure. And if they maintain or if they clean their filters, that can goes up till 25%. These are the some realistic pictures. So when we do power saving analysis, we put energy meter before implementation of our filtration within the existing filters whatsoever is client using, so that we can calculate the energy consumption from these energy meters, and after, let's say, 10 days, 15 days, we replace those filters with electronic or R filtration, and then again we measure the energy, so that there would be a realistic picture with the client how much energy they are saving in real case scenario. So it's all about the numbers. So whatsoever numbers we are gaining, we can make decision out of the same. So nowadays everybody is behind the numbers. So whether you want to do any AI model or machine learning, you should have plenty of data sets with you. Then only you can make a visualization of the same and make decision out of that. So this is our dashboard. As of now, we are collecting data and depicting in the form of air quality monitoring as well as historical data, which is a tool used for the calculations as well as for the uh, historical data calculations, and then it will be synced with the power saving so that we can get the exact picture out of the same. So this we are also upgrading, which I have mentioned earlier. So again, we are implementing ML and AI to the same so that client get the predictive analysis for the same as well. So I guess uh, this is as of now from my side. So these are some of the sites readings which we have maintained in some of these sites. So like pre and post analysis are there. So this is the trend, or this is the these are the facts or the figures which we always share as a case study with our client for their site. So before and after analysis. All right. So I would love to answer if any questions are there. So thank you. Thank you so much.